So good evening, parents. So today I'll be talking about the statistic analysis, which is about the product moment correlation coefficient. So before we continue about what is the product moment correlation coefficient, what is a line of best fit? So a line of best fit is a straight line that best represents the data on a scatter diagram. So here is two examples of scatter diagram, and here's the straight line that best represents the points. The line may pass through some of the point, all of the point, or none of the point. So in this diagram, the line passes through most of the point, but in here it only passes through some. So I'll explain what have I been doing in the past 2 weeks. So in the past few weeks, I went and asked 15 people of where they live and how long it takes them to come to school. So here's the screenshot of the house to school. So after I got the distance and the time of 15 people, I put them in a data table, and here's the distance of 15 people and the time. So after I put them in the table, now I plot a scatter diagram by using Excel. So what is R, or the product moment correlation coefficient? R is the measure of how closely correlated the two variables are. The closer to the point to the straight line, the closer to 1. So if the value of R is 1, it means that the line passes through all of the point with a positive 1 gradient. But if the value of R is minus 1, the line passes through all of the point with a negative 1 gradient. But if the value is 0, means that the line doesn't pass through any of the point at all. As you can see here, this one is negative gradient. So to calculate R, we have to find out these values first, which is the sum of x and the sum of y. So here's the 15 distance, and we plus them all together to gain the value of sum of x, and here's the sum of y. Now we have to find out the sum of x squared, the sum of y squared, and the sum of x squared. So we square each x, 3.3 square, and then we square all of them and then plus together to find the sum. And also do that to y to find the sum. Now we time x and y in each column, and now we plus them together to get sum of x, y. So after we have these 5 values, now we replace them in an equation to get sxy, sxx, and syy. And these 3 values are used to find the value of R. So here's my working to find out the value. So now after you replace the value in the equation to find R, you get the value which is 0.936, which tells you that the line of best fit will be quite reliable as it is close to 1 and it has a positive gradient. So now is the main thing we are doing. So we'll calculate the line of best fit exactly by using an equation of y equals a plus bx. So what is a? A is the y-intercept, which is the value where the line crosses the y-axis, and b is the gradient of the line. So to calculate the gradient and the y-intercept, you will need the same value, which is those 5 values and these one that we already calculated. So now we'll find the gradient, which is b. So we replace the value we have in the equation. And here's my working. So I replace and I found out b.
Year 9 math of Mr. Davis' class.
So, good morning, parents. And today I'll be talking about math. Right? So, it's gonna be presented by Mimi and I. So, have you ever wondered when you judge something, like this color is more prettier than this color, and how do we find that our agreement is the same? So, in today's presentation, I will be explaining to you how are we going to find that mathematically. So let's start off with Primi.
So these are the 8 pictures that we let our 8 students to draw it. And then after that, we will label each picture from A to H. Then after that, me and Matthew will be the judge, and we will judge separately, which one we like the most and which one we like the least, from 1 to 8. And these, judge 1 is Matthew and judge 2 is me. So you can see, right, some of the ranking is similar, but some might be different. After that, we need to find B, which is the different. So we need to minus judge 1 ranking with judge 2. And then we get the answer. And then we need to square the answer. And then we'll find the sum. This is the working of how we get the answer for this one. And why do we need to find this one? Because we need to use this in the Spearman rank coloration coefficient, which we need to find the RS. If our answer we get from doing that is 1, meaning our ranking is our agreement is totally same. But if we got -1, meaning we definitely disagree. So what he liked might be the one that I least like it, or the one that I like the most might be the one that he liked the least. And this one is the formula for the coloration coefficient ranking. So the big letter over there is called the sigma, which is to add up or to sum. And D is the different, and N is the number of pair of data. So to find RS, we need to replace all of those letters with the result from the last slide.
So that we have the table and we have the equation. Now let's find the solution. So as we know that we already did D, which we already found out, which is 8. That is already squared, so we don't have to square it. And N, which is the number of elephants, which is 8 elephants that we just saw. So we just simply add all of those numbers into that equation, and then it's equal to 1 minus 6 times 8 by 8 brackets 8 squared minus 1, which gives 1 minus 48 over 504, which is equal to the result 0.9. So 0.9, as Primi have explained for Spearman's correlation coefficient. So -1 is basically complete disagreement. We don't agree at all. +1 is we strongly agree. We definitely agree that our result is the same. And 0 is basically different opinions. We don't have a relation at all. We don't think exactly the same. So 0.9. So as you can see, 0.9, which one is the closest to 0.9? Which is 1. So our agreement is more or less agreeing. We strongly agree, but not totally, but we almost. So now let's talk about the graph. So as you can see, we have a table. To make it more simply to understand, we can draw it out on a graph. So if the dotted lines are in a straight line, we completely agree. But this one, there's a little bit of a dot going out. At first, we were going smooth. Our results are the same, 1, 1, 2, 2. But after that, we changed. I liked the third picture on the 3rd place. Primi liked it on the 4th place. Then on the 5th place, I liked the 5th place. Then she changed. So as you can see, at first we're going okay, but then not really agreeing. So yeah, that's more or less a straight line if you draw the line of best fit. So we have to thank to Mr. Charles Spearman, and today I'll be talking about Charles Spearman, who created and invented that equation and how to solve this mathematically. So he was a British man. He was born on September 10th, 1863, London, England. And sadly, he died at September 17, 1945, London. So, Spearman, he attempted to establish the general fundamental laws of psychology. So he learned psychology, and he wanted to make it into a mathematical way to solve it. Charles Spearman was an engineer. But before that, he was in the military. But he quitted the military to become an engineer because he thinks that science is more powerful. Then, after quitting the military again, he became a psychologist. That's where all the work began because he believed that science is more powerful. He had 3 daughters along with 1 son, but sadly they died early on 1941. And he was a professor also, he taught students, and he joined the facility of University College London in 1907 and was a professor at 1911 to 1931. So yeah, he did some decent teaching to the students. So next is by 1912, that's where he gathered the information. He hired scientists and he partnered with them to invent the G factor. What is the G factor? The G factor is the equation that we just saw. It's a general factor that to find our solution in a mathematical way. So yeah, Mr. Charles Spearman is pretty smart scientist. He was a psychologist. So that's all for today. Thank you, parents, for coming.